In this video, we are going to do two examples of just kind of picking information out of this shape. And so what we have is we have a hexagon that's drawn kind of within a circle. So the dotted line is not the diameter of the circle. It's just kind of the height of each of these triangles, where any of these lengths across from corner to corner are diameters of the circle. Okay, so we're going to try to figure out all the pieces that we can out of this. We have the base of the triangle, 6. So one of the things we need to figure out is what kinds of triangles do we have going on here? So we do have a hexagon, and we have 6 equivalent triangles here. So what I want to figure out is what's the measurement of kind of this top angle. All right, so I'm going to draw my picture of one of the triangles, and I want to figure out what this measurement is, because then I'm going to drop a height down. And I want to see what I'm cutting in half. So if you have a triangle, it's made up of 360 degrees total in here, and we're going to divide it by 6, which makes each angle at the top 60 degrees. So if that thing is 60 and we're dropping a height down, we're cutting it in half. So that angle is going to be 30, which makes this angle 60, which means we have a 30, 60, 90 triangle. So we have some relationships with that. So let me draw that off to the side. So our 30, 60, 90 triangle is, this side is x, the hypotenuse is twice whatever the shortest side is, and the height is whatever the shortest side is times the square root of 3. So let's see what we know. So all the way across is 6, which makes half of it 3. And then we have these relationships going on. So if that's 3, hypotenuse is twice that, the height is that measurement times the square root of 3, which is some decimal. 3 square root 3 is 1.20, 5.20. 5.20. All right, so let's see what we got. So we have all the bottoms are 6, all of these lengths are 6, and then that height is 5.2. So we should be able to answer quite a bit of information. So angle EOD, which is that top angle, is the same as this. So you're looking at 60 degrees for that. Angle COH is this angle, which is the same as the 30. So that's 30 degrees. BHO is the kind of the height that's dropped down. So that is 90 degrees. The radius would be the radius of the circle. So we're talking from the center out to any of these corners, which is that diagonal, which would be 6 inches. And then the distance across the corners, would be the diameter. And so it would be 2 6s added together. So you're looking at 12 inches. And then the last piece is FO. So FO is essentially a radius. So that's 6 inches as well. Okay, so we have one more version of that. It is also a hexagon, but this time this circle is kind of on the inside of it, so the hexagon is drawn to the outside. So it changes just a little bit, where this time the dotted line actually is the diameter, which would make each of these, that's a radius. But now each of these measurements out to the corner is bigger than that radius, because it kind of sticks out just a little bit. So we have, but we do have a hexagon. And so that really means that if we focus on one picture, one part of this, we're going to have an equilateral triangle, which is great. So we have this equilateral triangle that if we drop a height down, it's creating a 30, 60, 90. So let me just focus on the 30, 60, 90. All right, so we'll throw some measurements on it, and then let's generalize our relationships again with the 30, 60, 90. X, 2x, x root 3. All right, so we're probably going to use all that information. So let's just kind of throw some information in. So that dotted line total is 8, which is the diameter of that circle, which makes the height 4. All right, and then which makes this value 4. So if you're going backwards, so if you're taking this value and you're going to this value, if you go this direction, we would multiply a square root of 3. So if we're going backwards, we would be dividing by a square root of 3. So that 4, this value right here is going to be 4 divided by the square root of 3. Which I don't know. So 4 divided by square root of 3 is 2.31. So that value is 2.31, which is this. And then the hypotenuse is twice that. So if we double that, we get a 4, 6, and a 2. 4.62, which is also the same as this, which is the same length. Since this is a hexagon, all these triangles are equilaterals. So the total length across here is 4.62. These diagonals are all 4.62. The height is 4. And then kind of half of that is 2.31. So we should have everything that we need to answer any questions they throw at us. The distance across the flats are from this flat to this flat. So it ends up being the diameter of that circle, which is 8. Okay. If they said distance across the corners, then we'd be going from like an A to a D or any of those others. EO is this length, which is one of the diagonals. So 4.62 centimeters. And then the diagonal is going all the way across. And so that would be taking a 4.62 plus another 4.62. So 4.62 plus another 4.62, you're getting a 9.24. And then angle FED, which is this. Well, each of these corners, because it's an equilateral, would be 60. So that would be 60 and that would be 60. So the whole angle together would be those two added together, which is 120 degrees. Okay, and our other way of doing that is figuring out, we had that formula where you could have done 180 times the number of sides, which was 6 minus 2, and then divided by your number of sides. So this would give you 180 times 4, which is 720. And then if you divide that by 6, you get 120. And that 120 would represent the interior angles on every single one of those. But since we already knew the individual pieces because of our triangles, we don't have to do that, but this is just another option. All right, so that was a couple problems of just finding all sorts of information. And the great thing about it is both of those had hexagons in their insides. And so when you split them up, you get all these equilaterals, and then you cut the equilateral in half, you get these 30, 60, 90s, which have these nice relationships that kind of avoid any kind of Pythagorean theorem or avoid any kind of trigonometry stuff.